Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Okay, these are a few questions from chapter 12 and exercise 12.1. These are theorem exercises, mathematics class 10. The first question from Punjab textbook board book is: prove that in a given cyclic quadrilateral, sum of opposite angles is 2 right angles. So, first of all, we will draw it, and as you can see, there is a circle drawn over here. And in this, there is a cyclic quadrilateral ABCD. And there are certain angles A, B, C, and D, and we have to prove that the opposite angles, sum of opposite angles is 180 degrees. So angle B plus D, we have to prove that the angle is 180 degree, and angle A plus C, we have to prove that it is also 180 degree. Okay. What is the step of construction? In this we have to take, because in order to prove or in order to take the help of certain previous theorems, we have to make certain changes in the diagram. So we are taking this step of construction: join O to A and C. Here we have joined this O to A. This is point O, and let me write this as point O. This is point O. It's taking a little time. Sorry. Okay, here you can see this is point O. Right? We're joining this point O to A and C. And this is the cyclic quadrilateral ABCD. Here we have angle 1 and angle 2. Now, if we apply theorem 12.1, in theorem 12.1, we have seen that the central angle was double than the circumangle. So here angle 1, if we take this as the central angle, according to the diagram in which if O is the central angle and AC is are the 2 points on the circumference of the circle, then AOC, these are the 2 points A and C which are joined to the center of the circle. So AOC becomes the central angle, and D is another point on the circumference of the circle. So ADC, if we join A and C point to the center, it becomes central angle, and if we join A and C to some other point on the circumference of the circle, that is ADC, then angle D becomes the circumangle. So angle 1 will be twice the circumangle. Central angle is twice the circumangle. So angle 1 is 2 times angle D. And similarly, if we take angle 2 as the central angle, in which O point is joined to A and C, but if we join this A and C to some other point B on the circumference of the circle, then ABC will become its circumangle for angle 2. Now, if we are taking this as central angle, angle 2, the A and the point A and C, they are joined to this center, and this point, this angle 2 can also be the central angle. But for this, A and C will be joined to some other point for this to be the circumangle. And if we join point B with A and C, it becomes ABC, and ABC will be the circumangle for angle 2. So angle 2 will be twice angle B, which is ABC. So now we have got these two results, 1 and 2, and if we add the left hand sides, we have to add the right hand sides. We are adding angle 1 and 2. We are adding the right hand sides to angle B and plus 2 angle D, and angle 1 and 2, as we can see that if we add these two angles, sum of all the points on a given point is sum of all the angles will be 360 degree, as these are all the angles sum at a point. So it is 360 degree. and here 2 is common, and we are getting b plus t inside, and 2 when shifted over here it becomes 180. So sum of b and d has become 180, which is two right angles. And similarly we can prove for the other two angles. Now, question number 2 from exercise 12.1, show that the parallelogram inscribed in a circle will be a rectangle. So we have a parallelogram ABCD, which is inscribed in this circle with center O, and as it is a parallelogram, so its opposite sides will be congruent. So and AB side is congruent to DC side, and AD side is congruent to BC side, and also opposite sides are parallel to each other, so AB is parallel to DC. Now we have to prove that this is a rectangle. So in order to prove this quadrilateral to be a rectangle, or this parallelogram to be a rectangle, we have to prove the angles 90. So somehow we will prove that the angles are 90. So let's start. We will take the step of construction as joining of point A to point C, so that we can have two triangles, and in the correspondence of these two triangles, which are ABC and ADC, we are taking certain points. We are noting certain points so as to complete the formalities of some postulate. As we can see that AC is common in both these triangles. AB is congruent to DC, which are the given congruent sides. Similarly, AD is congruent to BC, which are the given congruent sides. So by collecting all these facts, we can see that the triangles are congruent because because of the side postulate. And as the triangles are congruent, so so we can draw certain results. Also we can have a result that angle B is congruent to angle D, because these are the opposite angles of the parallelogram, and any two opposite angles of parallelogram are congruent. So angle B and angle D are congruent. And from 12.4 theorem, we know that the sum of the opposite angles in which are inscribed in a circle is of 180 degrees. So according to theorem 12.4, this is a quadrilateral which is inscribed in a circle, and its opposite angles, angle B and D, the sum of these two will be 180 degree. And as these two angles are also equal, so the only option is that angle B and D will be 90 degree, and their sum will be 180 degree. And that is what we had to prove, that somehow that the angles are 90. So in this way we have proved that this parallelogram is a rectangle. Now let's see question number 3. In this question we are given that AOB and COD are two intersecting chords of a circle. So here we can see AOB and COD are the intersecting chords. They're intersecting at point O. What we have to prove, we have to show that these two triangles AOD and BOC, this triangle AOD and BOC, these two triangles are equiangular, means all their three angles, corresponding three angles are equal to each other. So we are given that AOB and COD are intersecting chords at point O, and we have to prove that triangles are equiangular, and we are taking the step of construction as joining with A point with C and C with B. And here we can see that angle 1 and angle 2, they are vertical angles, because these two lines are intersecting each other, and when two lines intersect each other, the pair of non-adjacent angles are vertical angles, and they are congruent to each other. And now we can see here, if we take this AC as a chord, as if this is a chord, so in this segment we have angle C, which is like here we have angle C, and angle 4. Here we have angle 4. So A is this one, and sorry, angle 3 is this one, and angle 4 is this one. Both start with A and end with C. Start with A and end with C. So the angles that are made like this, they are called the angles in the same segment of the circle, and here you have to focus on the chord. The chord is AC, so angle 3 and 4 are congruent. With the very same reason, if we focus on the chord BD, now start with B and end with D and see what angles are equal. B, D, angle 5. Again, I'm starting with B and ending with D, 5 and 6. So 5 and 6 are also congruent. So we had to prove that in this triangle, angle 2, 3 and 5, and in this triangle, angle 1, 4 and 6, they are correspondingly equal to each other. And here we have shown all of these three angles, they are congruent to each other. So BOC and AOD are equiangular triangles. Okay, now see the last question of this exercise 12.1, which is question number 4. We are given that AD and BC are two parallel chords of a circle. Here you can see AD and BC. They are two parallel chords in any circle. We have to prove that the arc AB and arc CD, they are equal, right? And we have to prove that arc AC and arc BD are equal. So we can prove by first of all, we have drawn it, and we have joined point B to D and A to C, and resultantly they are intersecting at some point M, and there are certain angles, angle 1, 2, 3, 4, 5, 6, 7 and 8. Now let's see how it is proved. First of all, look at this point, angle 1 and angle 8, how they are congruent. Now AD is congruent to BC, so these are, as they were given to us to be parallel to each other, so this BD behaves like a transversal, and the angles opposite to them are alternate angles. So angle 1 and angle 8 are alternate angles, so angle 1 and 8 are congruent to each other. Now angle 2 and angle 7 are also congruent to each other for the same reason. They are also the alternate angles. Now if we look at the chord CD, this chord CD, now I'm starting the angle from C and ending at D, and look at the diagram. C, D, angle 1, and C, D, angle 7. So angle 1 and 7, they are in the chord CD, and they are the same segment, and according to our theorem, they are congruent to each other. So angle 1 and C are congruent. So also we have seen that angle 1 is also congruent to angle 8. So angle 1 is congruent to two angles, angle 7 and angle 8. So angle 7 and 7 and 8 are congruent to each other. We will now be using this result in our triangle AMD. This triangle AMD. If angle 7 and 8 are congruent to each other, then their opposite sides will also be congruent to each other. The opposite side of angle 7 is MD or DM, and opposite side of angle 8 is AM. So AM and DM, these two sides are congruent to each other. These are the their opposite angles are congruent, so these two sides are congruent. Similarly, we can prove that BM and CM, with the same sequence of logic, we can prove this result, that BM is congruent to CM. Now result number 1 and 2 has been established. We will combine these two results, and we are adding these two results, right? So here AM plus BM, if I'm adding AM plus CM, I'm adding these two, so I'll be adding these two results also. AM plus CM will be equal to BM plus TM. Adding the two sides will result in the addition of the other two sides also. Now if we look at the diagram, AM plus CM is equal to AC, as you can see in the diagram. Let me show you. AM and CM, right? It is AC. And BM and DM, it is BD. Okay. From this result, now we proceed to another similar result, which is as AC is congruent to BD. We have reached to this result. AC is congruent to BD. Focus here in the diagram. AC is congruent to BD, right? So now with the same sequence of logic, we can prove that CM is congruent to BM, because CM and BM are the opposite sides of angle 1 and 2, and angle 1 and 2 are the equal angles in the chord BC. If you look at the chord BC, starting with B and ending at C, you get result 1 and 2 as congruent. And similarly, you will see that we have proved another result, AM and DM. They were all already congruent in result number 1, AM and DM. Here I have mentioned this result. Now I am adding these two results. AM plus CM is equal to DM plus BM. This result and this result, these two results are added. So AM plus CM is giving me AC, and DM plus BM is giving me BD. Now all the results have been gathered, and now we are ready to prove them congruent, prove the triangles congruent by some postulate. Let's see which postulate is applied. I'm taking the correspondence BC and BCD. BC is common to BC. It's obvious. Angle 1 is congruent to angle 2. We have proved it here. Let me show you. We have proved it here. They were the same, and they were the equal angles in the same segment BC, and they are congruent. And now AC and BC, we have also proved these to be congruent. So side angle side postulate is applied, and these two triangles are congruent. And if the triangles are congruent, then corresponding sides are also congruent, and AB and CD are congruent. So these are the corresponding sides of congruent triangles. So if two chords are congruent, then their corresponding arcs are also congruent according to our theorem. So arc AB will be congruent to arc CD. So in this way, we have proved this result also. I hope it is clear. Thank you, Allah Hafiz.